Okay, so today I'll be talking about using complementary methods to create Banksia woodland. That is, a mix of topsoil, direct seeding and planting. It is now 5 years since our team from the Banksia Woodland Restoration Project has been working to restore Banksia woodland. Started in 2011 and managed by the Department of Parks and Wildlife, the project was created to offset the clearing of 167 hectares of native vegetation at Jannacourt Airport. Part of this offset included the establishment of new Banksia woodland. So today I'll be talking about that aspect of the project, the work we have done to establish new Banksia woodland, how we monitored it, the results we've achieved and the challenges we've experienced. So the main aim of restoration is to establish vegetation that is self-sustaining and requires minimal future management using local provenance native plants. We also set targets for plant density and diversity based on data from flora surveys of Banksia woodland reference sites, including Jannacourt Airport. So firstly, we selected sites for establishing Banksia woodland. There are 2 restoration sites, Anktel Road in Jannacourt Regional Park and Forestdale Lake in Oakford. The sites both contain areas that were completely degraded and dominated by weeds. They were selected as suitable areas for restoration in that they match Jannacourt Airport vegetation, being a historically upland Banksia woodland within secure tenure and within 45 kilometres of Jannacourt Airport as stipulated in the offset conditions. We have now completed 5 years of restoration works covering 50 hectares at these 2 sites. Restoration began with a topsoil transfer from the cleared areas at Jannacourt Airport. This took place over April and May of 2012. The topsoil transfer was then followed up with planting from 2012 to 2015 and direct seeding from 2012 to 2016. Restoration works were done over a total of 11 hectares at Forestdale Lake and 39 hectares at Anktel Road. The first step of the restoration process was the topsoil transfer. In April and May of 2012, topsoil was transported from Jannacourt Airport and spread over 16 hectares of the upland areas at the 2 restoration sites, Anktel Road and Forestdale Lake. The topsoil was sourced from Jannacourt Airport Precinct 5 and was chosen as an area of good quality bushland that was free of dieback and relatively free of weeds. Here are just a few pictures to show you what we started off with. Both restoration sites were open paddocks dominated by weeds and very few scattered native plants. And this is immediately after the weedy topsoil was scraped off and topsoil was spread from Jannacourt Airport. As the site's home to both many kangaroos and rabbits, fencing was vitally important to reduce vertebrate grazing, in our experience anyway, and to ensure its success. So the fences were designed to keep out rabbits and to discourage entry by kangaroos. It's not quite tall enough to strictly be kangaroo proof. That wasn't affordable over such large areas, but it does still help to reduce grazing. So you can see on the picture the Adenanthus, they've been munching along the sides where they can reach in. The next step was planting, which has been important to supplement the topsoil germinants and to introduce the overstory species, which only recruited from the topsoil in very low numbers. We completed 4 years of planting at our restoration sites from 2012 to 2015. Using our own staff, external contractors and volunteers, we planted over 46,000 plants from 70 different species. Although we mostly used tube stock produced from seed, we also trialled production of plants from cuttings, enabling us to include species that are difficult to collect seed from or difficult to germinate from seed. We worked with a specialist nursery to collect cuttings from a number of species at Jannacourt Airport, which were then grown on and divided to boost numbers. 24 different species were produced by this method. It's a bit more of a labour-intensive method, and so it's more expensive as well. In addition to planting, we also used direct seeding to supplement the topsoil. Machine direct seeding was used to restore large areas of the site that had not received topsoil. As well as machine seeding, we also had hand seeding areas of the site, and that was useful for infilling areas that were inaccessible by vehicle. For both machine and hand seeding, the seed was bulked out with wetting agent, native slow-release fertiliser, sand and vermiculite. Both methods delivered the seed into shallow furrows and covered the seeds over with a thin layer of soil. From 2012 to 2016, 45 kilograms of seed from 80 different species was used. As Ankertel Road is the much larger of the two restoration sites, I'll be focusing the rest of my talk on that site. So before I go on to methods, I'll just recap the restoration works we've done at Ankertel Road. The total restoration area was 39 hectares, of which 11.5 hectares received topsoil, 32 hectares was planted, and 15.5 hectares have been direct seeded. We used three main methods to monitor the results on our restoration sites: 1 by 1 metre quadrats, 5 by 5 metre quadrats, and photo monitoring. The 1 by 1 metre plots were the first monitoring method we used. These were set up at 10 metre intervals along 6 transects. These are shown by the blue lines on the map. And these were established before the topsoil transfer to provide baseline data of what was present on the sites before any restoration works took place. After the topsoil transfer, we used these quadrats to monitor the species germinating from the topsoil. These small quadrats are still useful for monitoring seedling recruitment and small annual herbs. This is an example of one of our 1 by 1 quadrats, and if you can see the coloured pop sticks, they mark native seedlings which came from the transferred topsoil. The second method we used for monitoring are 5 by 5 metre quadrats, which we set up when the restoration sites were a little more advanced. The purpose of these quadrats was to cover a large proportion of our restoration sites and get a better estimate of the density of these species, especially the larger shrubs and trees. These were initially only set up in the topsoil areas of the site, where we had done most of the restoration works. But then this year we set up extra quadrats to cover all of the fenced areas, the restoration areas on the site, which had been more recently restored. From the beginning of the project, we have used photo monitoring to visually record the changes on our restoration sites. We set up permanent photo points before the topsoil transfer, taking photos from existing boundary fence posts and marking the outer edges of the photos with stakes on site to ensure we captured the same angle each time. The arrows show the photo points that we've set up at Ankertel Road. Photos were taken before the topsoil transfer and then twice every year, every spring and autumn. We also photograph our 5 by 5 metre quadrats each survey and our 1 by 1 quadrats, where photos are taken both upwards and downwards to capture changes in vegetation cover and variation across the site. These photos can also be run through a computer analysis to calculate foliage cover. As of late 2015, 159 species were present across our restoration sites. Our target was to return 60% of the native species recorded in the Janical Airport reference sites, although this target only applies to the areas that receive topsoil. The average number of species per quadrat at Janical Airport was 31 species, so this set our target for the restoration sites at 19 species per quadrat. At Ankertel Road, the topsoil areas had an average of 27 species per quadrat at the most recent survey in autumn this year, while last spring the average was 38 species. Even with this seasonal variation, species richness is comparable to Janical Airport bushland and exceeds our 60% target. The 159 species present at our restoration sites came from a number of different sources. The majority of species originated from the topsoil, while others came from direct seeding, planting, and local opportunistic species, which were already present in the restoration site seed banks or from adjacent bushland. There is overlap between these sources, so many species come from multiple sources. However, you can see just how important the topsoil was in restoring a large number of these species. Our target density for perennial native species was to establish 7,000 stems per hectare. Again, this target only applies to the areas which receive topsoil. This graph shows the percentage of quadrats which have reached that density target over the years. In autumn 2014, which was 2 years after the topsoil transfer, a little over 10% of quadrats had reached this target, while at our most recent survey, 64% of quadrats had reached target. Because of drought deaths over summer, we lose plants by the autumn surveys, but then gain new seedlings by spring. In our quadrats, we also measure foliage cover to track the restoration's progress. And as you can see from these one-by-one quadrat results, the perennial weed species have decreased. So that's the red line. The perennial natives are increasing, and the dotted lines are the annuals, which are variable. These 5x5 results show the increase in foliage cover in the topsoil areas of the site, grouped by growth form. Trees are at the top in the dark green, shrubs in the centre, and herbs, sedges and grasses in pale green at the bottom. So far, shrubs make up the vast majority of our foliage cover on the site, and tree cover is slowly but steadily increasing. Total cover is currently at around 20%. Our target for trees was to have all tree species that were in the reference plots at Janical Airport present on our restoration sites, which we do now. Another target was to establish at least 300 stems per hectare for all the tree species planted together. As of the latest survey this autumn, we have achieved this with 325 stems per hectare. Another important thing to note is that the tree species all came from planting and seeding, with only very small numbers germinating from the topsoil, none of those which we observed surviving. Many of the native species present on site originated from the topsoil seed bank, and so species richness is higher in the topsoil areas, which is the blue on the graph, compared to areas with no topsoil, and this includes, unfortunately, weed species. Plant density is generally much higher in areas restored with topsoil. So the areas without topsoil were first restored in 2014, 2 years later than the topsoil areas. With planting and seeding only, therefore targets may have to be adjusted for those areas. This graph is a histogram that shows the number of quadrats on the y-axis and the stems per hectare on the x. As things currently stand, most of the areas without topsoil, which is shown in red, are below the 7,000 stems per hectare, whereas the topsoil areas, though very variable across the site, have more quadrats at or above the target. An important aim of our restoration is that it will eventually become self-sustaining. Out of the 159 species present, there are 128 species flowering on the sites last year. Substantial pollinator activity and seed set have been observed in many species, an important step towards the sites becoming self-sustaining. In 2015, 3-year-old planted Banksia menziesii trees flowered for the first time, and last year produced mature seeds. And last year, Banksia attenuata and Banksia licifolia trees flowered for the first time at 4 years old. Here is one example of a photo point from our photo monitoring. This series showing the same location at Anketel Road in autumn of 2013, which was about 1 year after the topsoil transfer, and then again in autumn 2014, autumn 2015, 2016, and this was March this year. We also take photos each spring, so here's another example of a different location with photos from 2014, 2015 and 2016. As well as recording changes over time, photo monitoring is also useful to show the variation that exists across the restoration sites. These two photos are both taken at Anketel Road, the left photo is showing a 5x5 metre quadrat with the highest foliage cover and the right with the lowest. These quadrats are located within 100 metres of each other and receive the same treatments. This variability in results is shown on this map, which represents plant density for each of the 5x5 quadrats, with all of the green shaded quadrats having met the 7,000 stems per hectare target. The darker the green, the higher the plant density, while the red squares have not yet reached that target. There are some patterns to the location of the quadrats with poorer results. For example, these 4 on the western end are more upland. These 3 are located on an old track, and the ones on the west we're not quite sure, but they may be due to soil compaction. Low plant survival over summer is one of the major challenges for restoration projects. From 2012 to 2015, the first 4 years of our restoration, there have been major rainfall deficits. In 2016, we have had average rainfall, though this year is looking set to be below average again. Averaged across 4 years of planting, survival of tube stock was 39% at Anketel Road and only 16% at Forestdale Lake. And in a seeding trial of over 1,000 Banksia attenuata seeds planted on site last winter, the survival rate after 1 year was just 2%. The challenge of increasingly bad drought means we need to plan and allow for adaptation of the landscape. For example, including some upland species within the more dampland areas, with the likelihood that in the future these areas may only support upland vegetation. We did almost no watering on our sites because logistically it was too hard, particularly over a large site like Anktel Road. However, by not watering, only the most drought-tolerant individuals will survive, hopefully to produce drought-tolerant progeny. Planting and direct seeding over several years also helps to spread the risk of high summer mortality. We've done a rough comparison of the costs of the 3 different restoration methods. Note that these costs don't include management or monitoring costs. Direct seeding worked out the cheapest, around $12,000 per hectare over 4 years, planting at around $15,000 and topsoil transfer at $17,000 per hectare. Each method has different pros and cons. Direct seeding was the least expensive method. It allows the inclusion of species that may be difficult to obtain from nurseries, but requires a good supply of seed. With variable seed germination and summer drought losses, we found that planting was also required. Planting had fairly low and variable survival rates across the sites, and multiple years of infill planting were needed. Topsoil transfer, if done correctly, can give high species diversity, but relies on having topsoil available from good quality bushland, free of dieback and relatively weed-free, a rare occurrence. Topsoil did not provide the overstory species, so we needed to supplement with planting or direct seeding, and results were variable across the site. We've achieved good results so far in our restoration sites and are meeting the targets set, although it's still early days and our restoration sites so far are looking good in terms of diversity and density, with foliage cover steadily increasing. However, results are variable across the site and there are still areas that may require further work. In the case of our project, the topsoil transfer has been successful, providing the majority of species we restored to our sites. It can provide high species richness, plant diversity, plant density and the presence of recalcitrant species that may otherwise be difficult to obtain from nurseries or seed. However, it requires the availability of good quality topsoil, which needs to be used relatively quickly without being stockpiled for a long time. Also, topsoil alone did not provide adequate overstory, including a rather vital component of Banksia woodland, that is the Banksias, since these have canopy stored seed and rarely recruited from the topsoil. On the other hand, when direct seeding or planting only, the restoration was missing many of the smaller herbs and annual plants. We found that using a combination of these complementary restoration methods was the most effective in achieving these results.